Hello everyone, today I will show different type of data locations in Solidity. So whenever you're writing smart contracts in Solidity, you must be aware of your variables and data that are handled by EVM because the choice you're making will influence the total guest cost, the call of your functions and deploying your contracts, and the storage layout. So there are several types of data locations in Solidity. Mainly, they are divided into three parts. One is storage, that is store data permanently on blockchain, and another one is memory type, that is storing data temporarily for the need of execution, and that is deleted after the execution is finished. Lastly, we have call data, and that store function arguments that are passed in from an external caller. I will try to explain all of this with examples. So first of all, I will talk about storage variables. So all the variables and arrays declared outside of a function are normally state variables, and those are stored by the blockchain. So storage means data is stored on the blockchain directly. So you can also declare a variable of storage type inside of a function by using this keyword. That keyword is storage. So you can create this storage variable using two different methods. And lastly, storage variables are mutable, and they are very simple to explain, but they are very expensive. So here you can see an example of storage variable. So this variable is declared outside of a function. So these are state variables, and these variables are inside of a function. So these are local variables. So if I create a variable here at inside of this local scope using storage keyword, that will also become a storage variable. So I'll talk about how storage variables are stored in EVM. So they are always arranged in a compact way. So if it is possible to compact multiple values into a single storage slot, EVM will try to do that. So if these variables are less than 32 bytes, then these are combined, compacted to occupy the same slot. So otherwise, they will pushed into a new storage slot, and there are slot names starting from 0, 1, 2, 3, like that. And whenever we are using any dynamic arrays or structs, so in that case, it will always start from a new slot. And any variables following them will also be initialized in a new slot. So that means dynamic things always start from a new slot, and that is not combined with others. And finally, because of the size of dynamic arrays and structs, and that is unknown period, like they are unknown before execution, so they are assumed to take up 32 bytes, and it is computed using this hash function, that is kcac 256. So we have constant, and constant are also state variables, but that are not stored on a storage slot, and they are injected directly into contract bytecode. So whenever these variables are called, the contract automatically switches from their assigned constant value. Okay. So now I will talk about memory. So memory means memory is reserved for variables that are defined within the scope of a function, and they only persist while a function is called. Thus, temporary variables cannot be accessed outside the scope. So that means if you try to access this type of variables outside of a function, that is not possible. And finally, memory variables are mutable, so you can change them change their values. So here how memory variables are stored. So normally Solidity reserves 32 byte slots for memory, and that also combined 64 bytes of scratch space for hashing methods, then 32 bytes of currently allocated memory size, and 32 bytes of zero slot. I mean, that is for dynamic memory arrays. And because of this layout difference between storage and memory, the amount of space is always different. So I'm giving an example of storage and memory over here. So here we can see all of these variables are defined outside of the function. So these are storage variable, and this function has foo variable. It is called memory type. Okay. Here is an example how storage and memory type variables are different. So in both cases, the array is array. It is a array, and the struct, this is a struct or that have several integers over here. Str is occupies 128 bytes in memory. Okay, but for storage type, if it is stored as a storage type variable, in that case array only occupies 32 bytes and str will only occupy 96 bytes. So it will try to compact the variables as needed. So here is another example. This is a function called data location. It's taking an integer as an argument and it's returning integer and string. So here it's trying to return string as the storage variable because it's not defined here. So that's why if I run this function, it will say that data location must be memory or Calldata. So you need to add a keyword over here. So something like this. So in this function, we are returning a string that is memory type. So we are just returning a uint that is coming from here, and we are returning this string. And if you create a memory type variable here, this is a memory type variable that will also pass over here, and you can also do something like this, and you can also declare fixed size memory array like this. Okay, so in this example, it's trying to return a string that is memory type, but at the same time it is creating a storage type variable here, and this my copy, that is a storage type variable that is returned, that mismatches with this memory type. So we are getting this error that is saying it's not implicitly convertible. And finally, this example here, we have several variables. This variable is a storage variable. This variable is also a storage variable. So we have my structs, and we are trying to store the sender into my struct. So we are just doing something like this. And at this line, we are just creating an instance of my struct using this storage keyword. So it will be stored in the blockchain permanently. But in this case, we are using memory, so it will be removed from the storage after the execution finishes. And finally, if you want to initialize an array that is memory type, you must have to use a fixed sized array. So finally, we have a Calldata. So Calldata is only valid for parameters of the function, and Calldata is not modifiable like memory. If you declare a memory type variable, that is modifiable, but Calldata is not modifiable, and it's not persistent. So we have most likely memory, but it costs less gas and cannot override Calldata arguments. So this is a structure of call data. So call data is used to pass arguments to functions, and the first 4 bytes of call data contain the selector of the function signature, and remaining bytes contain the input parameters of the function. So let's say each input argument is always 32 bytes long. Then call data can be used to return values from the function. That return value is stored in the last 32 bytes of call data. And finally, the amount of resource for call data is available depending on the gas price. So normally it is unlimited, but because of the gas price constant, we have a specific amount of resources. So the higher the gas price, the more call data is available. So this is an example of memory and call data. As you can see, we are getting a memory type string and we are getting a call data type string, but while returning the string, we are always using memory type. So in this example is saying how much gas is needed. As you can see, for call data, the gas cost is much less than this memory type gas. And here we are using memory. And in this final example, we are using call data as a return type also, and we are using call data here, and it is this much gas. And here we have call data type argument, but we are returning it as memory. So that is for more gas uses here. And if we use memory for argument and memory for the return type, that have the highest gas uses. So then I want to talk about assignment operations. So assignment between storage and memory always create a separate copy. So if you want to store something from memory to let's say you want to create a storage type variable A, and that should come from a memory type variable B. So it will just create a copy. So assignments from memory to memory creates references. So therefore, changing one memory variable alters all other memory variables that refer to the same data. So that means if you have a memory variable, let's say M1, and let's say M2 is another memory type variable, and you just saying M2 is M1. So if you change the value of M1, it will also change the value of M2. And then assignments from storage to local variable also assign a reference. Okay, so all other assignments to storage always just copy. So let's talk about some opcodes related to call data. So there are mainly 3 opcodes related to call data. One is call data load, that allows loading 32 bytes word from the call data starting from a specific offset given as a parameter. Then we have call data size, that return the number of bytes containing in the call data. And we have call data copy, that copy a given number bytes from a source in the call data to a specific destination in the memory. So in the assembly, we normally use these 3 opcodes. Then call data is always having predictable format. So it will always begin with a 4-byte function selectors, and the function selector determined by taking kcac hash function, then that it trimmed. But this selector is hashed, then trimmed, and just 4 bytes are taken from here. So this function name will turn into this hexadecimal number. So here is an example how function is called in call data type. So here you can see we have 4 different types of arguments. Here we have an address, we have an integer, we have another integer here, and we have a bytes over here. So this whole function call will be converted to this byte code over here. So normally EVM will execute this byte code. So I can actually divide this bytecode into several chunks, into 32 bytes of chunks actually. So as you can see, this first chunk here, it is 32 padded version of our address. So we have this address over here that is padded with 0 and stored over here. And for chunk 2, this is the hexadecimal representation of number here. So it is a hexadecimal version. Then it is like verified. So if you use this program, it will give you like this particular number. So then the third chunk is this, the hexadecimal representation of 0. That means all of these are 0. Okay, so finally for bytes, we as this is a reference type and dynamic, so that's why it will expand to these 3 chunks. So first of all, in the first chunk we have 80, then we have C, and we have this particular data. So the first one is called the offset, and the second one is the length, and the final one is the value. And this is different from the address because the address is padded from the first, but this one is this byte is padded from the last. Okay, so if we use this function, this Python function to convert from hex, you will see bow tie table that is same as bow tie table over here. So that is all about Calldata in Solidity. Thank you so much.